Okay, we will go through the exemplar problems in the class 12 chemistry biomolecules, that is chapter 14. Okay, I will show you some general information. This is a aldehyde group where this carbonyl C double bond O carbonyl group, this carbonyl group is connected to at least one hydrogen atom, then it is aldehyde group. This is a ketone group where we have two carbon atoms connected to this carbonyl group C double bond O. Okay, two other carbon atoms are connected. This is ketone. This carboxyl COOH. This is amino group NH2. So this is carbonyl group C double bond O. This is hydroxyl group. Okay. In addition to that, from the haloalkanes and haloarenes chapter, you will learn what is chiral, enantiomers, optically active and inactive. Okay, let us take here what is chiral and asymmetric carbon. Let us take a structure of the glucose. This is beta D plus glucose. We have six carbon atoms here. Okay, so out of this there are 5 chiral carbon atoms. That means it is connected to 4 different groups. Okay, if we take the example of this carbon atom, so this is one group, two group, and this down complete, all the complete thing is considered as a one group. Then above one group, there are 4 different groups for this carbon. This is a chiral carbon atom. Similarly, if you take this third carbon atom, so here you take the third carbon atom, the above this is one group, second group, third group and fourth group, all are different. So when a carbon atom is connected to 4 different groups, then it is called chiral or asymmetric. So if you take this glucose structure, we have 1, 2, 3, 4, 5 symmetric chiral carbon atoms are there. This is not chiral because we have here 2 hydrogens connected to the same carbon. So this is not chiral. These other 5 things are chiral carbons. See here I will show you what is anomer. Okay, so you have to name the glucose starting one from here. There is the carbon atom which has the functional group. This is aldehyde group here. So from here 1, 2, 3, 4, 5. Okay, so the anomer is nothing but the first carbon. So first carbon, the OH group, side of the OH group differs, here right side, here left side. So only this difference, other things are same. Okay, so only the differs only at the C1, that is carbon 1. So this is called anomer. Okay, this is glucose structure and these two are anomers. So it only differs in the C1, carbon 1 position. This structure same glucose, but it is different, drawn in like cyclic form like this. This is called Haworth structure. Okay, alpha form, beta form. These OH groups are in the same side. These two, they are called alpha form. That is downward, OH is downward, alpha form. And this OH group on different side, this is beta form. Okay, OH group is upward here. That is, this is the anomeric carbon atom. Here OH group downward, here OH group upward. This carbon atom is after this O, oxygen. Okay. So what is nucleoside and nucleotide? See, if you connect a base at the one position, then it is called nucleoside. If you connect a phosphoric acid at the number 5, that is 1, 2, 3, 4, 5. Okay, here it is connected, phosphoric acid, then it is a nucleotide, phosphoric acid at number 5. Okay, so here what is the difference between the D and L configuration? So D configuration, this OH group at the last carbon, last asymmetric carbon. Okay, I already told you what is asymmetric or chiral. Last asymmetric carbon, the OH group on the right side, then it is a D glucose. If you on the left side, then it is this is on the left side, then L glucose. Now what is this plus? Plus means this dextrorotary. Okay, that means is related to the optical. It reflects the light on the right side. Where if you say a minus, then it reflects the light on the left side. So this is laboratory. Okay, this is plus and minus sign is for the optical activity. Okay, this is minus, this is plus. This is fructose, this is glucose. Okay, here this is minus. Glycogen is a branched chain polymer of the D-glucose, okay, alpha D-glucose units, in which the chain is formed by the carbon 1 and carbon 4 glycosidic linkage, whereas the branches occurred by the formation of the C166 glycoside. The structure of the glycogen is similar to this ampliopectin 9. See here, this glycosidic linkage is between C1 and C6. Okay, C6 and C1. Okay, this is carbon 1 is connected to the carbon 6. Okay, this is the this ampliopectin. Which of the following polymer is stored in the liver of the animal? Okay, this is glycogen. Okay, glycogen carbohydrate stored in the animal body. Okay, sucrose, canned sugar, is a disaccharide, that is 2 monosaccharide. One molecule of sucrose on hydrolysis gives 1 molecule of glucose. Sucrose consists of the glucose and fructose. Sucrose on hydrolysis gives the 1 molecule of glucose and 1 molecule of fructose. Which of the following pairs represent the ionomers? I already showed you. Ionomer is in the first position when other positions should be same. Okay. So here you see this structure of the glucose. You see only in the first OH is this side and OH is this side. Only this position is differs. Other things are same. So this is the ionomer. Okay. Hydroxyl group in the carbon 1. Carbon 1 means it comes from the functional group. This is the functional group 1 from 1, 2, 3, 4. Okay. At carbon 1 differs. Okay. Rest all same. Numbering start at the top functional group. Okay, the two cyclic hemiacetal forms of the glucose differ only in the configuration of the hydroxyl at C1 at carbon 1. Okay, these two differs only at the carbon 1. Here OH here and OH here. These two are ionomers. Okay. Proteins are found to have two different types of secondary structure, alpha and beta. Okay, structure alpha structure of the protein is stabilized by the hydrogen bonds. 13. Alpha helix is stabilized by Okay, this alpha helix hydrogen bonding stabilizes this hydrogen bonding stabilizes this alpha helix structure. Stabilized. Okay. Hydrogen bonds. In disaccharides, if the reducing groups of the monosaccharide, that is aldehyde or ketone groups are bonded, they are non-reducing sugars. Okay, when there is a bond between these aldehyde or ketone group and non-reducing sugar, which of the following disaccharides is a non-reducing sugar? This one is a non-reducing sucrose. Okay, this one is a non-reducing sugar. There is a bond between the this aldehyde group and this molecule 7. Okay, this one, this is the one. So this is a non-reducing sugar. Okay, since the reducing sugar of glucose and fructose involved in the glycosidic bond formation, sucrose is a non-reducing sugar. Which of the following acids is a vitamin? Okay, this is ascorbic acid. Okay, this is a vitamin C. Okay, dinucleotide is obtained by joining two nucleotides together by the phosphoric ester linkage. Between which carbon atoms of the pentose sugars of the nucleosides are these linkages are present between the fifth and third carbon atoms? So here between the fifth carbon atom and the third carbon atom is a linkage is formed. This is the third and this is the fifth. So this is the phosphorus diester linkage. Okay. Nucleosides are the formals of the nucleotides. That is, I already showed you right now. 19. These are the polymers of the nucleotides. Which of the following statement is not true about the glucose? Not true, they are asking. It is an aldohexis, 6 carbon atoms, so this is correct one. On heating the HA, this is also correct. It is present the fructose form. No, this is not true. Okay, this is for the fructose, not for the glucose. It does not give to this is correct. Okay, this is only wrong. This is not true. Each polypeptide is a protein as amino acid linked to each other by a specific sequence. The sequence of amino acids has to be primary structure of the proteins. This is the primary structure of the proteins. Okay, each peptide is in a okay, you can go through this. DNA, RNA contain 4 bases. Which of the following is not present in the RNA? Okay, which is not present in the RNA? See, DNA RNA contains 4 bases. Out of these, RNA contains 4 bases. First 3 are same as DNA. First 3 is same, but the last one is this. Okay. So instead of this thymine, it has this uracil. So this is not present. Instead of this, some other compounds is present. Which of the following B group vitamins can be stored in our body? This is vitamin B12. Okay, vitamin B can be stored except B12 can be stored. Okay, so the B12 can be stored in our body. Which of the following bases not present in the DNA? Okay, this is present in the RNA only. I already showed you. 3 cyclic structures of the monocytes are shown below. Which of these are monomers? Monomers, they differ only at the position C1 of the carbon atom. So only these differ. Rest should be same. Okay. So this one and 2. Which of the following reactions can be explained by its cyclic structure? Pentacetate of the glucose does not react with the hydroxylamine 5. Okay, this one. Absence of the CHO group. That shows the absence of the CHO group. Optical rotation of these some compounds along with the structures are given. Which of them is a deconfiguration? So that last asymmetric carbon atom, the hydroxyl group is on the right side, D. Okay, this is the last asymmetric carbon atom. Structure of the disaccharide formed by glucose and fructose is given below. Isobaric carbon atoms in the next to this this oxygen bond. Okay, here this one and here this one. A carbon atom in glucose and B carbon in the fructose. Carbon atom adjuncts to the oxygen in a cyclic structure of the anomeric carbon. 3 structures are given below in which 2 glucose units are linked. Which of these linkage is C1, C4 and which C1, C6? Okay. This is C1 and C6. This is C1, 1, 2, 3, 4, 5, 6. Okay, 4. C1, C4. This is C1, C4. C1, C6. Okay, A and C, C1, C4 and this is C1, C6. Okay, multiple choice questions. Carbohydrates are classified on the basis of behavior and the hydrolysis and also reducing and non-reducing sugar. Sucrose is a non-reducing sugar and it is having more than one monosaccharide. It has glucose and fructose. Sucrose has glucose and fructose. Okay, and it is a non-reducing. Sucrose is a non-reducing. Proteins can be classified in 2 types on the basis of their molecular shape. Fibrous and globular proteins. Examples of this protein is insulin and this albumin. Okay, 13. These are the common examples of the global proteins. Which of the following carbohydrates are branched polymers of the glucose? This amplifectin, I already shown you the C1C6 linkage, glycogen. Branched polymers, okay. C1, this is C166 and C1C4, C1C6. Glycogen also. These are the branched polymers. Amino acids are classified as acidic, basic and neutral depending upon the relative number of the amino and carboxyl group. Which of the following are acidic? Acidic means the more carboxyl group than the amino group. Okay, 1, 2. Two carboxyl group and only one amino group. The more carboxyl group, they mean acidic. Okay, acidic. Okay, acidic base depend on relative number of groups and carbonyl groups. Equal number of groups neutral. Amino group more number of amino groups then it is basic. Carboxyl more means is acidic. The lysine is basic, 1, 2 more amino group than the carboxyl group, then it is a basic. It is a amino acid. Okay, same carbon atom. This carbon atom has both amino group as well as carboxyl group. Okay, that is why it is the amino acid. Amine and acid. Amino acid is alpha position. Which of the following monosaccharides are present in the 5-member cycle structure of the proteins? Okay, this is given 6. Okay, fructose and ribose. Five-member ring and is named as furnace. In fibrous proteins, polypeptide chains are held by disulfide linkage hydrogen bonds. The peptide chains are parallel and held by this hydrogen bond and side disulfide bonds. Which of the following are appear in bases? Okay, this is the answer, but I don't know where it is in book. That's not in the book. Which of the following terms are correct about the enzymes? These are the proteins and biocatalyst. Okay. Protein, which about enzyme is a protein and biocatalysts. They are the enzymes or biocatalysts. They are the proteins. Name the sugar present in the milk. Okay, how many monosaccharide units are present in it? What are such polysaccharides called? And this is a lactose, okay, and that is present in the milk. Sugar present in milk is lactose. That is lactose. Two monosaccharide units are present. Such a polysaccharides are called disaccharides. Two monosaccharides are present. Okay. 2 to 10 monosaccharides present in the polysaccharides. How do you explain the presence of all 6 carbon atoms in a glucose in a straight chain? This is with a okay. This reaction with the on prolonged heating with hydrogen atom forms the N-hexane, supporting the 6 carbon are linked in a straight chain. Okay, because of this reaction with hydrogen iodide, we get this N-hexane that shows as a straight chain. How do you explain the presence of the all 6 carbon? That is okay. In a nucleoside, a base is attached to the primary position of the sugar. I already shown you in the notebook. Nucleotide is formed by linking phosphoric acid to the sugar of the nucleoside. At which position of the sugar unit is the phosphoric linked the nucleoside to get the nucleotide? Okay, this is 18. This is phosphoric at position 5 of the sugar moiety to of the nucleoside to get the nucleotide. Okay, here. So here it is linked to get the nucleotide. Name the linkage connecting monosaccharide unit in the polysaccharide. Okay. Glycosidic linkage. This is glycosidic linkage. Two monosaccharide through the oxygen atom called glycosidic linkage. Under what condition glucose is converted into gluconic and sucranic acid? Okay. 3, 4. Glyconic acid. This is glyconic acid and sucranic acid. Okay, these two from glucose. Glucose is converted to the gluconic by bromine water and the sucranic acid by the concentrated nitric acid. Monosaccharide contain carbonyl group. Hence are classified as aldose and ketose. The number of carbon atoms present in the monosaturated nucleotide are also considered for the classification. In which class of monosaturates will be fructose? Fructose is a ketohexose. Ketohexose. Fructose is a ketohexose. Okay. The D and letter L letter before the stereoisomer also indicate the correlation of the configuration of the particular stereo. This refers to the relation with one of the isomers of the equalizer. Okay. Predict whether the following compounds are D or L. D means hydroxyl group of the last asymmetric carbon on right side. Okay. Last, this is L configuration. Okay, this is for D configuration on the right side, L is on the left side. Okay. OH group, lowest asymmetric carbon atom. Left side means L, right side means D. Okay, this is D and L configuration. OH group on the right side means D, OH group left side means L. Aldopentose, named as repository, are found in nucleic acid. What is the relative configuration? What is the relative configuration? Okay, these two are that configuration. Which sugar is called the invert sugar? Why it is called 7? This is invert. The hydrolysis of the sucrose brings about a change in the sign of the rotation. Okay, hydrolysis of the sucrose, change in the sign of the rotation from plus to minus. That is why it is called invert sugar. Okay, sucrose is invert sugar. Amino acids can be classified alpha, beta, gamma, all those things. So depending upon the relative position of the amino group with respect to the carboxyl group, which type of amino groups form polypeptide chain in the proteins? This one, amino group, carboxyl group, the same carbon atom, that is alpha. Alpha helix is the secondary structure of the proteins formed by twisting the polypeptide chain into a right bonded screw-like structure. Which types of interactions is responsible for making it the helix structure more stable? Okay, this is hydrogen bonding. In helix structure chain stabilized by the formation of the hydrogen bond between the NH group of the amino acid in one turn with the carboxyl groups of the amino acid belonging to the adjacent term. So this is how it is stabilized. Okay, you can go through this here. Some enzymes are named after the reaction, okay, when they are used. What name is given to the class of enzymes which catalyze the oxidation of one substrate with simultaneous reduction of the another substrate? This one. Enzyme. So this is the oxidation and reduction simultaneously taking place. During the curdling of the what corresponds to the sugar in the present in it is converted to the lactic acid. Lactic acid. Curdling of the milk is present in the formation of the lactic acid by a bacteria present in the milk. What do you explain the presence of the 5-OH group in the glucose molecule? Glucose pentosylate derivative and acetylation with acetic anhydride. This confirms the presence of the OH group. Okay, this on acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirm the presence of the OH group. Okay. Why does compound A given below not form the axamine? Okay. This is glucose pentaacetate. Glucose pentaacetate structure does not have free OH group at the carbon position 1 C1, so it cannot be converted into the open chain form. Okay. Glucose does not react with hydroxylamine. Okay, because of the absence of this. Why must vitamin C be supplied regularly? Because it's a water soluble. 44. Vitamin C water soluble, therefore it is readily excreted in urine and can't be stored in our body. So the water soluble vitamins must be supplied regularly, okay, because they are excreted in urine and can't be stored in the body. Sucrose is dextrose, but the mixture obtained on hydrolysis is explained. So 45. On hydrolysis, sucrose gives glucose and fructose. Okay, 45. Okay, here it is given, you can go through it. So an hydrolyzed glucose fructose. Amino acids behave like salts rather than simple amines or carboxylic acid. 46. The aqueous solution, the carboxyl groups loses a proton, amino group accesses a proton to form a sweeter ion. Okay, to both the ions are present. Okay, this is formation of the sweeter ion. Both positive and negative ions are present. Okay, you can go through this. Structure of the glycine and alanine are given below. Show the peptide linkage in the. Okay, 47. So this is this linkage, okay, between this alanine and glycine. Dual. Okay, this linkage. Okay. Protein found in the biological system with a unique three-dimensional structure and biological activity are called the native proteins. When a protein in its native form are subjected to the physical changes like temperature or the chemical change in pH, denaturation of the protein takes place. Explain the cause. Due to the physical or chemical change, hydrogen bonds in the proteins are disturbed. Globules unfold and the helix gets. Therefore, the protein is the biological activity. This is called denaturation of proteins. Okay, this is the denaturation of the proteins. Activation energy of the acid catalyzed hydrolysis of the sucrose is this much. Energy is only this much. When hydrolysis is catalyzed by the enzyme sucrose. Enzymes, the biocatalysts reduce the magnitude of the activation energy by providing the alternative path. The hydrolysis of the enzyme sucrose reaches the activation energy from reduces the activation energy. Okay, here is, so you can go through this. How do you explain the presence of the aldehyde group in the glucose molecule? Glucose reacts with the hydroxyl to form the monoxins and add the molecule of the hydrogen cyanide to give it contains. Okay, is 50. Okay, this reaction. Which molecules of the nucleosides are involved in the formation of the phosphodiester linkages present in the dinucleotide? What does it want? 1. Okay, this is those diester linkages, phosphodiester linkages. What are the glycosidic linkages? Which types of the biomolecule are present? Okay, this is the glycosidic linkage. Linkage between the monosaccharide and using the oxygen atom. Which monosaccharide present in starch, cellulose, glucose? Okay, 53. In starch and glycogen, glycosidic alpha linkages is present. Cellulose beta linkage is present between the glucose unit. How do enzymes helps to substrate to be attacked by reagent effectively? Active sites of the enzymes hold the substrate molecule in a suitable position so that it can be attacked by the reagent effectively. Describe the D and L configuration of the amino acids with the example. Okay, this is the D and L configuration. Plus and minus D and L. How do you distinguish the primary secondary hydrogen present in the glucose? You explain the reactions for. This is the primary, okay. Coagulation of the egg white. Boiling is an example of the desaturation of proteins. Explain the terms of the structure of protein. Due to the denaturation, okay. Matching type, vitamins and their associated diseases, okay, is given in the 16. Okay, these are the vitamins and these are the deficiencies, okay. Match the following given below, okay. These are the some of the compounds. Invertose, okay, hydrolysis of the cane sugar. Maltose, this is the enzyme catalyst. Hydrolysis of the maltose into glucose, so this is used as a catalyst. Pepin, this is hydrolysis of the proteins into peptide. Urease, this is the one. Zymes, this one. Deep glucose is dextrose in nature. Yes, this is correct. D represents the no. This is plus represents the dextrose. D for the that OH group is on the right side. Plus is the optical activity. Okay. Plus sign is the this dextrose. Vitamin D can be stored in our body, correct? Vitamin D is a fat soluble. This is the correct reason. B glycosidic linkage is present in the maltose, so not it should be the alpha linkage. Maltose composed of two glucose units, which of the C1 and the glucose C4 of the another glucose. This is the correct. All naturally occurring alpha amino acids except glycines are optically active, correct? Most naturally occurring amino acids have the L configuration. This is not related to this. DLN, no relation with the optical activity. Is optical activity is denoted by the plus and minus sign. D and N is nothing to do with. Assertion this is wrong. Carbohydrate or the carbon. No, so compounds which is wrong. Glycine must be taken through diet. That's wrong. It's an essential amino. No, essential aminos are given on the table. The presence of the enzyme substrate molecule can be attacked by the reaction effectively. This is correct. Active sites of the enzyme score the substrate molecule. Okay, the correct reason. Write the reactions of the D-glucose which can't be explained by the open structure. Okay. Open chain structure. Okay, this behavior, this glucose, this reaction can't be explained by this open chain structure. On the basis of the evidences, the D-glucose was sustained in the following structure. Okay, you can go through these structures. Why they have arrived at this? Carbohydrates are essential life in both plants and animals. Name the carbohydrates that are used in the storage molecules in the plants. Carbohydrates used in storage molecules in plants is starch, and in animals it is glycogen. Cellulose is present in the wood or in the fiber of the cotton cloth. This is cellulose. Explain the terms of primary secondary structure of proteins. So what is the difference between the helix alpha and the beta? Okay, primary structure and this alpha beta helix structures, so you can go through it. Write the structures of the fragments produced by the complete hydrolysis of DNA, how they are linked to DNA molecule. Draw the diagram to show the pairing of the molecule bases in the double helix of the DNA. 17. Okay, these are the structures, you can go through it. Okay.